In this video, we'll explain other ways that we can prove similarity between triangles. We can use the AA similarity postulate or the angle-angle similarity postulate to prove the following two theorems. The first one is side-side-side or SSS similarity. And this says that if the corresponding side lengths of two triangles are proportional, then the triangles are similar. So if we look at these two triangles, JKL and MPQ, we can see the color-coded lines match up. So let's start with the red one. JK here over MP here is going to equal LK or KL over PQ is going to be equal to, so the ratio or the proportion is going to be equal to LJ over QM. So this means that if one segment increases or decreases by a certain amount, the corresponding segments on the other triangle are also all going to increase or decrease by that same amount. And if they are all proportional, we can say that the triangles are similar to each other with our similarity statement. The next one is side-angle-side similarity. So in this one we have a side here, RS, XY. We have a similar angle here, S and Y, so that they're equal. And we have another side, so side, angle, side. If the lengths of two sides of one triangle are proportional to the lengths of the two corresponding sides, and the included angles are congruent, so they're equal to each other, then we can say the triangles are similar. So we have to check for proportional lengths of two corresponding sides and included angle. So the included angle means the angle between the two segments are equal to each other or congruent. So if RS here over XY equals ST over YZ, so those two segments are proportional and angle S equals angle Y, then we can say these two triangles are similar as well. Let's take a look at the proof for this. So if we're given AB over FG equals, let me mark this up as well. So if we have AB, so this segment over FG equals BC over GH, BC over GH equals AC over FH. So we want to prove that given this information here, that the triangles are similar. So in order to do that, we're going to find a point here, J, on FG, so that GJ, or JG, this segment equals AB. And then we're going to draw a line, JK, that's parallel to the line FH. So we're going to draw this line right here. And we're going to label GJK, this angle here, as angle 1. So this angle G up here is equal to G by the reflexive property, which just means that something is equal to itself. And then we can say angle 1 equals angle F. So this angle and this angle are equal to each other because these two lines are parallel and these angles are corresponding angles. So then we can say that GJK is similar to GFH by the angle-angle similarity postulate. Next, by definition of similar polygons, we can say that JG over FG, so this part, over this part, equals GK over GH, this part, and then we have that JK, so this part here, over FH is also equal to that same ratio. So by substitution, since we said that JG equals AB, we can plug AB in for JG. We get AB over FG equals GK over GH equals JK over FH. And since we're also given that AB over FG equals BC over GH equals AC over FH, so we're given that up here. This is our given. Then we can say that GK over GH, because GK over GH we said here is equal to AB over FG. So we can say if it's equal to AB over FG here, we can say that GK over GH equals BC over GH. And similarly, JK over FH equals AC over FH. So this means that GK equals BC, JK equals AC. So GK is congruent to BC, and JK is congruent to AC. So by our side-side-side theorem, we can say that these two triangles, ABC and JGK, are going to be congruent to each other. And then by CP-CTC, or corresponding parts of congruent triangles, we can say that angle B equals angle G. So this angle here equals that angle there. And A, this angle here, is equal to angle 1. And since 1 equals F, this one here, by the transitive property, we can say that ABC is similar to FGH. So our transitive property we used here, we're saying if 1 is equal to F, so if this angle here is equal to this angle here, and A is equal to F, so this one is equal to F, then A is going to be equal to 1 as well. Let's take a look at an example. Determine whether the triangles are similar. If so, write a similarity statement. Explain your reasoning. All right, so to prove whether these are similar, in this first one we have 3 sides for both these triangles. So we have this triangle here, and then we have this triangle right here. So in order to prove that they're similar, we want to say that the ratios of one side to the other side in the different triangle are equal to each other. So we can say R is PR over SR. So this segment right here, PR over SR, is that going to be equal to PQ over ST? And is that going to be equal to QR over TR? So QR is this one, and then TR is this one. So if all these proportions are equal to each other, then we can say that these triangles are similar. And if we calculate this out, we get PR over SR is 2/5, PQ over ST simplifies to 2/5, and QR over TR simplifies to 2 over 5. So 50 over 125 equals 2 over 5. And so we can say, yes, these are similar. So when we write our similarity statement, we want to make sure we say it in the right order. So PQR is similar to STR by side-side-side similarity theorem. Okay. And let's take a look at the next one. We have triangle AEF and ACB. We can see here that they share this angle here. So if they share that angle, let's take a look and see if the sides also are proportional. So angle A is angle A equals angle A by reflexive property, just means something equals itself. And if we calculate AF over AB, so it's going to be AF here over AB. We're going to see if that equals AE, this part, over AC. And when we calculate that out, we get AF over AB is 10 over 10 plus the 5 here equals 10 over 15, so that's going to give us 2/3. And AE over AC also reduces to 2/3. So we can say then, since the lengths of the sides that include angle A are proportional, AEF and ACB, and we want to make sure we write it in the right order, are going to be similar by our side angle side similarity theorem. Let's take a look at one more example. So in the figure, ADB is a right angle, so it tells us that we have this right angle here. Which of the following would not be sufficient to prove that ADB, so this triangle, we want to prove that this triangle, ADB, is similar to BDC, BDC. So let's see, we're given that ADB is a right angle, and we need to figure out how to prove ADB and BDC are similar. So since ADB, this angle here, is a right angle, we also know that BDC is going to be a right angle. And since all right angles are congruent, they're all equal to 90 degrees, we can say that our angle ADB, this angle, is equal to BDC. So we have two angles that are equal to each other. Now we need to see, are the proportions of the sides do we have proportions of the sides that are equal to each other? So let's see what the different information they gave us. For A, we have AD, so AD over BD, so AD over BD, AD over BD equals BD over CD. So if AD over BD equals BD over CD, and ADB, so this angle here, equals this angle here, then we have a side, an angle, side, angle, and a side that are equal to each other. So by side, angle, side similarity, we can say that triangle ADB is similar to triangle BDC. Now let's see, what if we only knew that, I'm going to clear some of these drawings out here. Let's say we only knew that AB over BC equals BD over CD. So AB is this one over BC is equal to BD over CD. BD over CD. So if those are equal, and then we also know that these two angles are equal, we have an angle of side AB and BD, but this angle here, the reason we can't prove that these are similar triangles is because this angle here is not the included angle. It's not this angle right here. We need this angle right here if we were wanting to prove that these two triangles are going to be similar. It has to be the angle in the middle of the two segments we're comparing. So since this is not the included angle, then this information would not be sufficient to prove that triangle ADB is similar to triangle BDC.